Imagine a world-class sporting event, tens of thousands of cheering fans, and elite athletes, all gathered in the middle of a searing hot desert. It sounds like a paradox, doesn't it? Yet, in recent years, this has become a reality. Building a massive stadium in one of Earth's most unforgiving environments poses extraordinary challenges that push the boundaries of engineering, sustainability, and human ingenuity. Today, we're diving deep into this fascinating topic, exploring how these architectural wonders rise from the sands, what it takes to make them functional, and the significant trade-offs involved in such ambitious projects. Let's unpack the core issues one by one. The most obvious challenge is, of course, the heat. Desert climates are characterized by extreme temperatures. During summer months, average daily temperatures can soar to 45 degrees Celsius, or about 113 degrees Fahrenheit. This isn't just uncomfortable, it's dangerous for athletes, spectators, and even the building materials themselves. Unmitigated, such heat would render any outdoor event impossible and create unbearable indoor conditions. Tackling this requires sophisticated, energy-intensive solutions that redefine stadium climate control. To combat this heat, engineers deploy a combination of active and passive cooling systems. Active systems include massive air conditioning units and specialized field cooling technologies. These often involve pumping chilled air directly into the seating areas and onto the pitch through thousands of strategically placed nozzles. Passive solutions incorporate the stadium's design, reflective exterior materials, strategic shading elements, and natural ventilation principles. Think of it as a giant, sophisticated thermos bottle, constantly fighting off the external heat to maintain a comfortable interior climate, even with an open roof. Now, let's talk about the energy cost of these cooling marvels. Maintaining a comfortable temperature in a desert stadium is incredibly power-intensive. A single large desert stadium can demand up to 30 megawatts of electricity to operate its cooling systems at peak capacity. To put that into perspective, 30 megawatts is roughly enough electricity to power around 20,000 average homes simultaneously. This immense energy draw raises significant questions about sustainability and the carbon footprint of such projects. Given the vast energy consumption, the carbon footprint of desert stadiums is a major point of controversy. If this electricity comes from fossil fuels, the environmental impact is substantial. Critics argue that hosting events in such environments undermines global efforts to combat climate change. However, some projects are attempting to mitigate this by integrating renewable energy sources. Solar farms, for instance, can offset a portion of the energy demand, but meeting 100% of a 30 megawatts requirement purely from renewables is a monumental task in itself, requiring vast land areas for solar panels. Beyond energy, water is perhaps an even more critical resource in the desert. Building and operating a stadium requires significant water for various purposes: cooling towers, irrigation for green spaces like pitches, restrooms, and general cleaning. In a region where water is incredibly scarce, every drop counts. A large stadium can consume upwards of 15,000 liters of water per day for these operations, equivalent to the daily needs of over 1,000 people. Sourcing this water responsibly is a complex and often expensive endeavor. To address water scarcity, innovative solutions are imperative. One common strategy is desalination, a process that removes salt and other minerals from seawater to produce fresh, potable water. While effective, desalination is energy-intensive and can be costly. Another approach is extensive water recycling and greywater systems, where water from sinks and showers is treated and reused for irrigation or cooling. This closed-loop system significantly reduces the demand for fresh water, embodying a principle of maximal efficiency. Building in the desert isn't just about the finished product. The construction phase itself presents monumental logistical hurdles. Transporting vast quantities of materials, steel, concrete, glass, specialized equipment, across remote, often unstable terrain is a significant challenge. Roads need to be built, infrastructure established, and a temporary city sometimes created for thousands of construction workers. The harsh climate also impacts workers' safety and productivity, necessitating strict regulations and innovative scheduling to avoid peak heat exposure. The choice of construction materials is critical. Traditional materials might degrade quickly under intense UV radiation and extreme temperature fluctuations. Architects often opt for durable, high-performance composites, specialized glass, and concrete mixes designed to withstand the harsh desert environment. Furthermore, sand erosion is a constant threat. Wind-blown sand can abrade surfaces, clog ventilation systems, and impact structural integrity. Designs must incorporate features like protective barriers and self-cleaning facades to mitigate these effects, adding layers of complexity and cost. Let's compare the financial investment required. Building a conventional stadium in a temperate climate is already a multi-billion-dollar undertaking. However, adding the unique challenges of a desert environment significantly inflates these figures. The advanced cooling systems, desalination plants, specialized materials, extensive logistical infrastructure, and higher operational costs for energy and water push the budget much higher. While a major urban stadium might cost around $1.5 to $2 billion, a desert equivalent can easily exceed $5 billion, sometimes much more. Despite these monumental costs, nations often choose to invest in desert stadiums due to significant economic justifications. These projects are frequently tied to major international events, which serve as powerful tourism magnets, attracting millions of visitors and boosting local economies. They also create a lasting legacy of infrastructure development, including new roads, public transport, and hospitality sectors. Furthermore, hosting such events projects a powerful global image, fostering national branding and diplomatic influence on the world stage. Beyond the technicalities, ensuring human comfort is paramount. The goal is to create an environment where spectators and athletes can enjoy the event without discomfort or health risks. This means not only controlling temperature but also managing humidity, glare, and air quality. Advanced sensor networks continuously monitor these conditions, making real-time adjustments. The design also considers the flow of people, providing ample shaded areas, hydration stations, and efficient entry/exit points to minimize exposure to the outdoor heat. The construction of a desert stadium is also a massive employment generator. During peak construction phases, projects can employ tens of thousands of workers. Our research indicates numbers as high as 60,000 for some megaprojects. This influx of jobs can significantly boost local economies and provide valuable skills development. However, it's crucial to ensure ethical labor practices, fair wages, and safe working conditions, especially in such challenging environments, to guarantee a positive social impact. Accessibility is another crucial element. A stadium, especially one in a remote desert location, requires a robust transportation network. This often involves building new highways, dedicated metro lines, or advanced bus rapid transit systems connecting the stadium to major urban centers and airports. The aim is to move large crowds efficiently and safely, minimizing travel time and exposure to the heat. For instance, well-planned integrated transport can shave 45 minutes off an average fan's travel time to the venue, greatly enhancing the overall experience. Looking ahead, the future of desert stadiums is likely to be shaped by continued technological advancements and increasing pressure for sustainability. We can expect to see more integration of AI-driven climate control, even more efficient renewable energy solutions, and revolutionary material science that offers superior insulation and resilience. The emphasis will shift further towards creating net-zero or carbon-neutral venues, making these incredible structures not just engineering marvels, but beacons of environmental responsibility. The trade-offs will always exist, but the balance will lean towards greater harmony with nature. In conclusion, building a stadium in the desert is a fascinating balancing act between ambition, engineering prowess, and environmental stewardship. It's a testament to human determination to overcome natural barriers, creating spaces for global connection and entertainment. While the challenges are immense, from battling extreme heat and water scarcity to managing vast energy demands and logistical complexities, the solutions showcase incredible innovation. As technology evolves and our understanding of sustainable practices deepens, we will undoubtedly see even more extraordinary and responsible desert venues rise from the sand, redefining what's possible in architecture and event hosting.